Okay, thanks girls. Okay, volunteer for the first one. Say it again, please. 54. Can we all stop the chatter, please? Okay, x equals 54. The angle at the circumference is half the angle at the centre. Number 2, we've got two answers, x and y. New people. Amy? Okay, so you took both the answers off everyone else. Any reason? Hey. No, I don't. I don't. The same segment. We talk about the same arc. Okay, so x and 33 are sitting on the same arc, so they're equal to each other. And on the top arc, 49 and x and y were sitting on the same arc. Okay. They're not vertically opposite. The only angles that are... Ooh. Whoa. Desktop. Where stop? Where? Oh, okay. Okay, no, there's no vertically opposite except those two. There are no other vertically opposite angles in that shape. Okay, number 3 is the harder one, Maisha. 50. Some steps? 50 is the right answer, but I need some steps. Okay. So it's an isosceles down the bottom. So there's another 40 there, you said. Good work. And then that makes that half of it. Okay. So at this stage right now, were there any particular questions from the homework? Because you're going to get bookwork day time today, but there's no specific ones. What I want to do is a little bit more theory on the circle stuff. And then the rest of the lesson will be bookwork, or does Mr. Coe want to hand out the investigations right now? Okay, so we are paused. Okay, so today we're looking at, and this will take about no more than about 5 minutes or so, we're looking at chord properties. So we were having angles, now we're looking at chords. So in my particular diagram, I've got a circle and I've got a chord over here on the right, and I've got a chord down the left. And I've drawn it very carefully so that you don't see these like there's straight lines going through the center to the other chord. So I put a stroke through here and a stroke through the other one to prove that if chords have equal length. Okay, so copy that down and then we'll do the theory. Okay, so we've got two triangles formed and I've marked two angles at the center, and the first thing I'm going to say is, does anyone know what the two angles might be equal to each other? Why? Just because they look like it? Okay. So, angle at the centers are equal. But there's a reason why, and it's nothing to do with the arc they sit on, but there is a reason. And while we're still going, Maisha? So what sort of triangles do we have formed? Starts with letter C. No, not equilateral. Not equilateral. We've got isosceles. We've got isosceles triangles, but they're congruent. So the reason that the angles at the center are equal, because we've got two congruent triangles. Girls, so we've got the two blue lines on the right and the two purple lines on the left. They're all radii, and I've said that the third side is equal. So we've got the triple S. And once we've got triple S, then we have angles are the same. So that's the reason why. And the other thing that I haven't drawn is the distance from the center, which I've marked in green lines, those distances are also the same. So we say that the chords are, now this is the word equidistant. So if the chords are equal, their distance back to the center must also be equal. Okay, so copy that down. Okay, there's a property that if a line from the center cuts the chord into two equal bits, it makes a right angle. So a line from the center Does anyone know what the mathematical word for cutting a line into two equal bits is called? Bisecting, thank you. A line from the centre that bisects a chord, it makes a right angle. Okay, just from that, we're not saying that statement just then. Okay, so there's three opposite statements. So the opposite statements are, if a line, guys, if a line bisects a chord, it must be at a right angle. So if a line bisects a chord and goes through the centre, it must be at a right angle. Okay, so if a line bisects a chord, it must be at a right angle. Or the last one is, if a line at a right angle bisects the chord, it must go through the centre. So there's a few other theories you can read backwards and forwards. So those sort of questions might be in that form, but basically they're the two theories you have to worry about, and as far as I know, I think that's all we have to worry about. This is 10A stuff, yeah. So this won't be in the core test, no. So what I'm going to do is I'm going to list the exercise, but you're more than welcome to go back to the angle properties that you may not have finished. So I'm just going to list the exercise. So it's exercise 8.7, and again we've got fluency, understanding, I've got to talk to Mr. Coe about that and the other two. You're not going to be assessed against it on your grades. Okay, so the exercise to go with chords is 8.7, but we're more than happy if you want to go back to the 8.6 stuff to finish that off as well. And that's it for the day.